Acids have some general properties in common. They taste sour. They will dissolve many, but not all metals. They will turn blue litmus paper to a red color. Litmus is a substance that changes color depending on the pH that it's in. And so blue litmus paper turns red in an acid, and acids will neutralize bases. And then here's a table listing some of the common acids. We learned to name most of these acids in Chem 1A. Citric acid, I would not expect you to know the formula for, but the rest of them, from the nomenclature you learned in Chem 1A, you should be able to name and write the formulas for those. What I would like you to just generally be familiar with is what these acids are used for. Hydrofluoric acid is very aggressive, and it can actually be used to etch glass. So you can't keep hydrofluoric acid in a regular glass bottle. Citric acid is present in citrus fruits. Because it's a naturally occurring acid in food, they use that to adjust pH in food because, you throw a little lemon juice in there or something. You can adjust it. Fertilizers, sulfuric acid and nitric acid are used a lot in fertilizers. Acetic acid has that distinctive smell of vinegar because vinegar is a very dilute solution of acetic acid. Hydrochloric acid, real common acid, used for cleaning metal. It is used in food preparation. And I think the biggest thing is it's the primary component in your stomach acid. So just have a clue about these. Don't just ignore this table, okay? Bases have general properties that are kind of opposite of acids. They have a bitter taste rather than a sour taste. They feel slippery. The reason they feel slippery is because they react with the oils on your skin to make soap. But eventually, they will dissolve your skin. There's two kinds, this is just kind of bonus material here. There are two kinds of drain cleaners. If you look at the labels, some of them have like hydrochloric acid in them, and others will have lye or sodium hydroxide or potassium hydroxide. If you have a hair clog in your bathtub and you don't have a septic tank, get the kind with the sodium hydroxide in it because it will dissolve that hair like you would not believe. And the acid one will not touch it at all. If you have, like we had a problem with the toilet, used the metal auger on the toilet and got these all nasty marks from the metal on the toilet. Well, the sodium hydroxide drain cleaner did nothing to that, but the HCl, the hydrochloric one, dissolved the metal off of the porcelain. And so little tip there. Yeah, so they feel slippery. Since we have plenty of time tonight, I'm going to tell you a gross story. Just because I can. First week of grad school, they made us watch this safety video. And the thing I remember from that is they were talking about clothing and stuff, and they told this story and showed pictures of this guy. He had been wearing boots in the lab, and he spilled some sodium hydroxide, a fair amount of it, on his clothing, and he didn't bother to take his boots off. So there's sodium hydroxide on his socks, and he didn't really feel anything at first. If you get acid on your hand, it begins to sting fairly quickly. The base, it feels slippery, but how would you feel slippery on your feet inside your boots? When he took his boots off, it had dissolved a lot of the skin off of his feet. And they showed a picture of that, and it was just really sickening. So, acids, people are scared of acid, but in my view, just in terms of contact, acids are a lot less dangerous than bases are. Many of the foods we eat are acidic. We have acid in our stomach, but bases can be very toxic. They dissolve tissue. And one of the reasons for this bitter taste, and the reason that humans generally do not like bitter taste, is due to alkaloids, which are organic bases found in plants. And these are often poisonous. You've heard of hemlock,
Yeah.
right? I guess Socrates drank hemlock poison and killed himself. That's an alkaloid base. Tastes nasty, very, very bitter. So bases are generally not real biocompatible. Bases do the opposite with litmus paper. If you have red litmus paper, it turns blue. So there's another one of those. Acid and base, red and blue, how do you remember them? Base starts with B and blue starts with B. And the base will turn the litmus paper blue. Bases neutralize acids. And then there's this table. There aren't as many common bases. Sodium hydroxide, potassium hydroxide, sodium bicarbonate. This is the main ingredient in baking soda, and it's also used as an antacid. Sodium carbonate is a water softener. It's in a lot of detergents. And then ammonia. And if you've ever used a household cleaner that's basic, it feels very slippery, right? Because when it contacts oils, it forms soap out of them. And so it's really good at degreasing things. You might wonder, well, I told you that horror story about bases in skin. How can you eat sodium bicarbonate, which is a base, and not have it destroy your stomach? Well, there are strong bases and weak bases, and we're going to learn about those.